So how do we approach limits that involve infinity? When infinity is not an actual numeric value, it is only a concept. And then how do these limits help us understand the behavior of a function? So when we talk about limits involving infinity, we're talking about going infinitely to the right or left, or infinitely up or down. And those concepts are asymptotes. And asymptotes is something that you already know a little bit about. We've got vertical asymptotes, we've got horizontal asymptotes, we've got slant asymptotes, but that's not really part of this lesson. But the idea of what is happening at our end behavior or whenever a function shoots up or down. That's what we're worried about when we talk about limits involving infinity. So let's go ahead and use this function here to determine what our asymptotes are. So we've got a vertical asymptote is going to be, in this case, where the denominator is equal to 0. We're always concerned about the denominator whenever we deal with vertical, because we're working with a function where it does not exist, right? Where does the function not exist at all? So that's going to be at x equals 4. If I was going to draw a vertical asymptote, we usually do that in a dashed line to indicate that my function is not touching that. It's going to be really, really close to it, right? But it's not going to touch it. And then for the horizontal asymptote, we worked a little bit with like acronyms. BOBO, BOTN, each DC is a really common way for us to work with horizontal asymptotes. But ultimately, you're looking at how am I growing in the numerator and the denominator, and am I growing at the same rate? So that's the idea of a horizontal asymptote. So if you distribute this, right, the top would end up being the 2x plus 2 over x minus 4. So as I get really, really, really large, right, this plus 2 and this minus 4, they don't really mean much. So I'm going to end up with a 2x and an x. So this is an each DC acronym, right? So that stands for exponents are the same. So we're going to divide coefficients. That's what that stands for. So you're going to have a horizontal asymptote at y equals 2. So that's your horizontal asymptote. So again, let's get that pieced in here. So I've got a little bit of a quadrant set up, and now I've got to figure out what's going on in each of those quadrants, right? Exactly what is my graph doing? So there's a few different ways that you can do this. I think it's really beneficial for you to know what the x-intercept is. Well, how do you find the x-intercept? The x-intercept is going to be where the numerator equals 0. Because where the numerator equals 0 is where y is going to be 0, which is the x-intercept. So that's what we're going to do. We're going to take this piece right here. We're going to set that equal to 0. Got to do a little bit of algebra, but ultimately we end up with x is equal to -1. So again, I know that this function is going to cross right here at x equals -1. I could plug in a few points around the 4 to determine if I'm positive or negative. So what I could do is I could take a 5, right? And if I plug in a 5 here and a 5 there, do I end up with a positive value or a negative value? Well, I end up with a positive value. So that means I'm going to have to be dealing with a function that kind of looks like that, because I'm going to have to stay positive values. I wouldn't be down here, right? Because then I would have negative values, and that doesn't make any sense. So I hope that you're kind of piecing a little bit of that together. And once I know that piece, this really helps, because now that I have that x-intercept, that's my general graph. So limits involving infinity, knowing what the graph looks like really matters. Limits involving infinity are twofold. We are working with end behavior, which is what is going on as x approaches negative infinity, and what is going on as x approaches positive infinity. Then you are also looking around the vertical asymptote. So let's talk about that piece first. So let's talk about what the vertical asymptote is doing. So it's easy, right, to identify a vertical asymptote, because that's going to be where we're going to shoot up or shoot down, and we're going to either be going to positive infinity or negative infinity. If the function behaves differently on either side, then obviously no limit exists. If I'm approaching 4 from the right and the left, I'm not approaching the same value. On one side, I'm approaching positive infinity. On the other side, I'm approaching negative infinity. Okay, but if the function does behave the same, we have what we call an infinite limit. So if on both sides I'm shooting up, we would call that an infinite limit. On both sides, I'm shooting down. We would call that an infinite limit. Now, I will say that infinite limits get a little bit treacherous and that there's still some debate about exactly what's going on because infinity is not a value, right? Infinity is a concept. So how can it actually be a limit if I'm only approaching a concept? I'm not approaching a value. So NLE is certainly acceptable whenever we talk about approaching 4 from the right or the left. Even if both of them, but from each side we were going the same direction, NLE is certainly an acceptable answer. It's safe to say that no limit exists because we are unbounded. We're not approaching a specific value. Okay, for our example, okay, we're going to describe the limits around the vertical asymptote. So let's do that. We're going to write out our limit correctly. So we're taking the limit as x approaches 4 from the left of f of x. Remember, you got to take the limit of something. You can't just take a limit of nothing. So if you're going to approach from the left, you're going to end up on this side, which means you are going to negative infinity. And then if you are going to approach x equals 4 from the right, again, you're approaching from the right of f of x, you are going to be approaching positive infinity. Those are what we would consider infinite limits. Now, if you had answered NLE to either one of those, that would be acceptable, but it doesn't tell me anything about the function, right? I want to understand the function's behavior, so that gives me a lot more information about the behavior of the function. But if I did ask you, what is the limit as x approaches 4 of f of x? You have to consider that you're coming at it from the right and the left, and since you are not approaching the same value, that would be no limit exists.